we have already learned that exhaustive testing is not possible. So we need techniques to identify test cases with the most likelihood of finding a defect out of the possible many. There are many test case designing techniques available. Let's look at them, one by one. Equivalence partitioning. It is a black box technique, which can be applied to all levels of testing like unit, integration, system, etc. A black box technique is a technique where the code is not visible to the tester. In this technique, you divide a set of test conditions into partitions that can be considered the same. To understand this with an example, let's consider the behavior of tickets in the flight reservation application while booking a new flight. Ticket values 1 to 10 are considered valid and ticket is booked for these values. Values 11 to 99 are considered invalid, and the error message, "Only 10 tickets may be ordered at one time," is shown. On entering values 100 and above, the ticket number defaults to a 2-digit number. On entering values 0 and below, the ticket defaults to 1. We cannot test all the possible values, because if done, number of test cases will be more than 100. To address this problem, we use equivalence partitioning. We divide the possible values of tickets into groups or sets, where the system behavior can be considered the same. These sets are called equivalence partitions, or equivalence classes. Then we pick only one value from each partition for testing. The hypothesis behind this technique is that if one condition or value in a partition passes, all others will also pass. Likewise, if one condition in a partition fails, all other conditions in that partition will fail. That is all to equivalence partitioning. Next technique is boundary value analysis. In this technique, you test boundaries between partitions. As in our earlier example, instead of checking one value from each partition, you will check the values at the boundaries like 0, 1, 10, 11 and so on. Boundary value analysis is also called range checking. Equivalence partitioning and boundary value analysis are closely related, and are generally used together at all levels of testing.